The purpose of this video is to introduce you to the concept of lateral and surface areas of the cylinder. First of all, we have to talk about what a cylinder is. A cylinder has two bases that are both parallel and congruent, just like the prism. Unlike the prism, though, the bases of the cylinder are in the shape of a circle. And these circular bases are connected by a curved surface that makes up the lateral area of the cylinder. Now, when we draw the net of the cylinder, we can see that it really consists of three different parts. I'm going to call one of the circles the top, the other circle the bottom, and then this curved surface that makes up the lateral area. So the lateral area is the curved surface, and you can find the lateral area by multiplying the circumference of the circle times the height of the cylinder. Or sometimes we say lateral area is 2 times pi times r times h. The surface area includes not only the curved surface of the lateral area, but also the area of the two bases that make up the top and bottom of the cylinder. In the first example, they're asking us to find both lateral and surface areas for the cylinder shown. In part A, they want us to express our answer in terms of pi, and in part B, they want us to round our answer to the nearest hundredth. So I'm going to go ahead and write down my formula for finding lateral area. Lateral area is equal to 2 times pi times the radius of the cylinder times the height of the cylinder. And then I'm going to go ahead and multiply all of the things that I know, or substitute all of the things I know into my formula. So for pi, I'm going to use the pi button on my calculator, so I'll leave that alone. The radius of my cylinder is 2.8 meters. And the height of my cylinder is 3.7 meters. Since we've been asked to find the lateral area both in terms of pi and to the nearest hundredth, when I go to get my calculator out, into my calculator, I'm going to type in all of the factors except for the pi. I'm going to type in the 2 times the 2.8 times the 3.7. When I do that, my calculator tells me 20.72. But I still haven't multiplied times the pi yet. I still have a pi in my answer. Area is always measured in squared units, so I can either say squared meters or meters squared. So there's part A, my lateral area in terms of pi. In order to find that lateral area rounded to the nearest hundredth, I'm simply going to grab my calculator, and I'm going to punch into my calculator 20.72 times, and then the pi button on my calculator, and then I'll go ahead and hit enter. And when I hit enter, I find that the lateral area is about 65.0937, and then some more decimals. And they want me to round this number to the nearest hundredth. So to that spot right there. So my lateral area is 65.09 square meters. All right, so there's the lateral area. The other thing that they wanted me to find for this cylinder was surface area. And I know the surface area is going to consist of the lateral area, plus the base that makes up the top of my cylinder, plus the area of the base that makes up the bottom of my cylinder. The lateral area we already found, 20.72 pi. The area of the base we don't know, but we can find fairly simply because we know that the base is a circle, and we know that the formula for finding the area of a circle is pi times r squared. So I'm going to come over here under my cylinder, and under my cylinder I'm going to go find the area of each circular base. Once again, I'm going to get out my calculator, and I'm going to remember that Aunt Sally says I have to do exponents before I can do multiplication. So when I square that 2.8, I end up with 5.6. So the area of my bottom circular base is 5.6 pi. The area of my top circular base is 5.6 pi. And again, I'm going to go ahead and grab my calculator. And in my calculator, I'm going to add the 20.72 plus the 5.6 plus the 5.6. And I end up with 36.4 pi in either square meters or meters squared, however you're feeling comfortable expressing yourself. And then for the second part of that, in order to round that to the nearest hundredth, I'm going to go ahead and grab my calculator, type in 36.4 times pi. And when I type that into my calculator, I get 114.3539, which I need to round to the nearest hundredth, that place right there. So to the nearest hundredth, the surface area of my cylinder is 114.35, either square meters or meters squared, however you're comfortable expressing yourself. All right, so there's a little bit on lateral area and surface area and how to find them. The second example is very interesting, I think, because we have to work backwards. In this particular case, we're given the surface area, and they want us to find the height of the can. Since they don't provide a picture, I'm going to go ahead and draw a cylinder. The way I draw a cylinder is by drawing two parallel and congruent circles, and then connecting those circles with my lateral area. All right, so the radius of this cylindrical can is 6.5 inches. We know the surface area is about 592.12 square inches, and they want us to find to the nearest inch what should be the height of the can. So I'm going to let X be the height of the can. Since this question deals with surface area, I'm going to use the formula for surface area. I know that surface area is made up of lateral area plus the area of the base on top plus the area of the base on bottom. I'm now going to go ahead and substitute everything I can into the formula. So I know the surface area is 592.12. The lateral area I don't know. I could find it by multiplying 2 times pi times my radius times my height. This is starting to get a little bit uncomfortable here because now we have both a pi and an x. I'm going to go ahead and multiply the 2 times the 6.5. So lateral area is 13 times pi times x, or 13 times x times pi. I'm not going to plug that into my formula just yet because I'm a little bit uncomfortable with having these two factors multiplied times the 13. I'm going to go see what I've got next in my formula, my area of my base, and see if I can find that. My bases here are circles. We know the radius, and once you know the radius of a circle, it's fairly simple to find the area. So pi times the radius squared. And again, I'm going to punch into my calculator the exponents first. So when I punch in that radius of 6.5, my calculator tells me 42.25 pi. So I'm going to go plug that in here for area of the base. And now I'm going to clean up my equation a little bit. So when I go combine those two, the 42.25 plus the 42.25, so when I go ahead and combine those, I end up with 84.5 pi. To isolate the lateral area, I'm going to subtract 84.5 pi from both sides. So I end up with 592.12. Subtract 84.5 pi on the left. And on the right, I have my lateral area. But I knew that my lateral area was equal to 13 times pi times x. So I'm going to go back in and substitute 13 times pi times x. And in order to find x, keep in mind that this is the variable here that I'm solving for. To undo a multiply times 13 pi, I'm going to divide by 13 pi. And if I divide the right side by 13 pi, I have to divide the left side by 13 pi as well. So now on the right side, I've isolated x. On the left side, I have the 592.12, subtract the 84.5 pi, all divided by 13 pi. So x comes out equal to about 7.9982 and then a whole bunch of other stuff. So to the nearest inch, the height of my can is 8 inches. So that's a nice fun little problem with a lot of good algebra in there, a lot of abstract thinking with the x's and the pi's. I'm going to have you go summarize what we did here on this page up at the top of the next page. And then, like always, see if you can apply what you've learned in order to solve problems 2 and 3 on the next page.